Hello! Looking at section 1.1 to 1.3, we have 15 problems here with lots of different concepts. This first one here, we're just simplifying the expression by factoring out the largest perfect square. So we're looking at numbers like 4, 9, 16, 25, and so on. And so my largest perfect square that goes in there is 11 squared, which is 121, and that is multiplied times the square root of 5. I cannot reduce the square root of 5. It is a prime number, so there we go. This does reduce into 11, and so when we write these expressions, we always put the whole number in front. So this is 11 root 5. Number 2, we are simplifying, but we are using a different index. We're using 3 instead of 2. And so this means we're looking for what 3 products will give us negative 125. So unlike a square root, where we can have a negative number, here we can because we're dealing with 3 products. So the square root, or I'm sorry, the cube root of negative 5 times the cube root of negative 5 times the cube root of negative 5 is simply 5. Here we're going to be using the product rule or the quotient rule, which is where we can simplify numbers with exponents. So if we see a number written as 2 to the negative 6th power, that is the same as 1 over 2 to the 6th. 2 to the 7th power is the same as 2 to the 7th over 1, and I complete that for the rest of the products. And then here I wrote it all together. And then we use the quotient rule, which allows us, if we have the same base, we can simply subtract their exponents. And you're like, if I do subtract that, where do I put this number? You simply put it where you have the larger exponent. So 7 minus 6 is 1, and since 7 is larger than 6, I put that on the numerator. And then here I have 4 minus 3, which is 1. 4 is larger, so therefore I put it on the bottom. And since we are youngsters here with our big boy and big girl pants on, we don't need to put that exponent of 1. We simply write it as 2 to the 7th. Here in 4, we're doing the same thing, except not only with numbers, we're also using variables. So we have the same base here, meaning I can simply subtract those and get 2. Since this is larger on the bottom, it stays on the bottom. I can reduce 4 over 32 and reduce that 4 goes into 4 once, and 4 goes into 32 8 times. And I subtract 9 and 3, giving me 6. And that stays on top. So this is our final solution. On number 5, we need to keep in mind here, this negative sign or opposite sign is not being included in this. It doesn't really matter since we have an odd exponent. But if you have an even exponent, that does matter because this is on the outside. So if this was squared, this would still end up being negative 25. But in my case, this is a cube, so it really doesn't matter. So I still end up with a negative 125 plus 35. And as we simplify, we get negative 18. In this next one, it is best to go ahead and solve for y, since that is our independent variable, and x is our dependent variable. And so we do that here. And then once we get that process done, I'm simply plugging in or evaluating at these x values. So I plug in 0 here. I end up getting 6 for my y, and so on. And then I simply take these points and I put them on the coordinate plane and create our line. And number 7, we're doing the same thing there. We're making sure we solve for our y value there. Just keep in mind when we are dividing by any coefficient of y, we need to make sure that we are dividing all terms. Here, this is saying we're evaluating when x is negative 3. So this is how that looks. So we're not multiplying f times negative 3. This is saying that f represents some function, and here it is here. And we are plugging in for all x values the value of negative 3. And here's what I was talking about earlier. And so here, negative 3 is included in this square, so therefore it's negative 3 times negative 3, giving us a positive 9. We multiply here, we get a negative 21, and we evaluate. Here is a fancy way of just simply writing negative 4, 6. I am plugging in the x value of negative 4, so my x value is negative 4, and when I do that, I get 6. And if we look up at this one above, we could write this as f of negative 3 equals 3. So if we were to write it as an ordered pair, it would be negative 3, 3. And in this case, it's negative 4, 6. Here, we're looking at x-intercept, y-intercept, domain, range, and the slope of the line. So when we're looking at the x-intercept, that tells us that our y value is 0. So I simply plug in 0 for y and solve for x. And then for my y-intercept, that tells me that my x value is 0. So I plug in 0 for x, evaluate. My domain is a set of x values that pairs with a y value. And so every x I pick and plug into this function, I am going to get a y. So there isn't an x value that I cannot plug in, or if I plug in, it doesn't have a paired up y. And then the range is when we evaluate that domain, what are the values of our y values? And we can see that they go from negative infinity to positive infinity. So think negative infinity meaning I'm coming down here. So I'm coming from the bottom and I'm going all the way to positive infinity. So we'll read these from either left to right for domain and bottom to top for range. And then looking at our slope, we can simply look at the value there. In this equation, we can see that our x values are the same, and we have a vertical line, which lets us know that we just simply say x equals whatever that x value is. And that lets us know that we have undefined slope here. 12, we're just finding slope, so this lets us know that we are going to be subtracting our x values on the bottom and subtracting our y values on the top, and evaluate and simplify. 13 is an example of where we do have the same x values, just like the graph above. And when we do subtract those, we cannot divide by 0, therefore we are undefined. So this would also be a vertical line. Here we have a horizontal line, therefore that means we have 0 slope. So if we rewrite this equation, y is equal to 0x minus 7, it lets us know that we have 0 slope, and we should have a horizontal line like so. In our last problem, we're simply graphing this. We're starting at the point negative 2, 3 with the red dot, and our slope tells us that we're going up 1 and to the right 2. And we must also keep in mind that this line goes in both directions for infinity. So therefore, we can also say that our slope is negative 1 divided by negative 2. So I'm going down 1 and to the left 2.